In this video, I want to talk about how to use use substitution with definite integrals. And there are two ways we can use substitution for definite integrals. The first way is we do not change the original bounds. Okay, so the first step is um, we solve for this indefinite integral. So we're trying to find what is the antiderivative. Um, suppose that it's a function capital Fx, right? And once we find out this function capital Fx, then we use the first fundamental theorem of calculus. Then we can know this definite integral equals the capital Fx will x from 1 to 5, which equals capital F of 5 minus capital F of 1. Now, so here is the idea. So the first thing is we need to know, what is this guy, okay? And we can find this by using use substitution. All right. Let's think about first. Let's think about which term should we let it be u. So here we have this term. This quantity 2x minus 1 is under the square root. So I decide to let u be 2x minus 1. If u is 2x minus 1, then du over dx gonna be the derivative of this equals 2. Therefore, dx gonna be 1 over 2 times du. Okay, now we substitute u for 2x minus 1, and we substitute 1 over 2 du for dx. So our original indefinite integral we can write as x over the square root of u and times 1 over 2 du. Now we still have an x we need to get rid of. To do this, to get rid of this x, we can use the method back substitution. Since u equals 2x minus 1, then u plus 1 equals 2x, and then x equals 1 over 2 times u plus 1. So we can replace this x by 1 over 2 times u plus 1. Okay, now let's simplify this function. So 1 over 2 times 1 over 2, that is a 1/4. So I write outside and u plus 1 over the square root of u. Now the square root of u we can write as a u to the power of 1/2. And then we can split this into u over u to the power of 1/2 plus 1 over u to the power of 1/2 du, which equals u to the power of 1/2 plus u to the power of negative 1/2. Okay, now we can split this, since this is an integral of a sum of two functions, we can split this into a sum of two integrals. The first one is the integral of u to the power of 1/2 du plus the integral of u to the negative 1/2 du. Then using the power rule, we can solve for each integral. So get u to the power of 1 over 2 plus 1, 2 plus 1 plus u to the power of negative 1 over 2 plus 1 over negative 1 over 2 plus 1 plus a constant. Okay. So this is 1 over 4 times u to the power of 3 over 2 over 3 over 2 plus u to the power of 1 over 2 over 1 over 2. And we flip these two fractions and put it in front of each variable. So we have 2/3 times u to the power of 3 over 2 plus 2 times u to the power of 1 over 2. Okay, then since u is 2x minus 1, so we have 2. Okay, let me distribute the 1 over 4 into this first. So I will get 1 over 6 times u to the power 3 over 2 plus 1 over 2 times u to the power of 1 over 2. And then we bring the x back. We substitute 2x minus 1 for u. So this is 2x minus 1 to the power of 3 over 2 plus 1 over 2 times 2x minus 1 to the power of 1 over 2. Okay, so this is the antiderivative of this function. So this is our capital Fx. This is our capital Fx. And then this definite integral x over 2x minus 1 dx gonna equal this, where x from 1 to 5. So to find the answer to this definite integral, we first evaluate this function at 5, and we evaluate the function at 1, and we find their difference. So when x equals 5, 2 times 5 is 10. So this is 10 minus 1, that is 9. This is 1 over 6 times 9 to the power of 3 over 2 plus 1 over 2 times 9 to the power of 3 over 2, and minus when x equals 1, 2 times 1 is 2, 2 minus 1 is 1, and 1 to the, so this is 1 over 6 times 1 to the power of 3 over 2 plus 1 over 2 times 1 to the power of 1 over 2. Okay. So let's see what is a 9 to the power of 3 over 2 equal. We can see this as the square root of 9, because we can see this as a 9 raised to the power of 1 over 2, and then raised to the power of 3, and 9 raised to the power of 1 over 2, we know that is a square root of 9. And the square root of 9 is a 3. So 3 to the power of 3, that is 27. So 9 to the power of 3 over 2 is 27. And 9 to the power of 1 over 2, we see here is a 3. The square root of 9 is 3. And anything raised to the power, so 1 raised to anything equals 1. So this is 1 over 6 plus 1 over 2. Okay. So we have 27 over 6 plus 3 over 2 minus 1 over 6 minus 1 over 2, which is 27 minus 1 over 6 plus 3 over 2 minus 1 over 2. So we have 26 over 6 plus 1, which is 26 over 6 plus 6 over 6, which is 32 over 6. So the answer is 32 over 6. Okay. So this is the first way we can do the we can use the use substitution to solve for this definite integral. Now the second way, I'm still use the same example. The second way is we change the lower bound and the upper bound. We change the bounds. Okay. So what does this mean is okay, after we use use substitution, after we find out the antiderivative. Now before we bring the x back, the antiderivative is returned into u, right? Okay. So the antiderivative now is returned into u. Is 1 over 6 times u to the power of 3 over 2 plus 1 over 2 times u to the power of 1/2. Is 1/2. Okay. So this is like this integral. After I write this integral in terms of u, so it becomes this 1 over 4 times u plus 1. So after I solve for this integral, I got this where u is equal to 2x minus 1. Okay, the second one is I don't bring the x back. Now I evaluate this function at two new bounds, and the bounds are given by this formula. So the new lower bound is when x equals 1. So if x equals 1, 2 times 1 minus 1, that will give us the new lower bound. And this new upper bound still use the same formula when x equals 5. This is 9. So this is like after we do the u substitution, we can rewrite the original definite integral into a new definite integral. Now this definite integral is written in terms of u, and the lower bound is 1 and the upper bound is 9, and the function is this. The function inside the integral is this. And because we see that the antiderivative for this integral, the solution to this integral is this. So the answer to this definite integral is equal to 1/6, where u is from 1 to 9. Okay. So when u equals 9, this is 1/6, 9 to the power of 3/2, plus 1/2 times 9 to the power of 1/2, and minus when u equals 1, it's 1/6, 1 to the power of 3/2, plus 1/2 times 1 to the power of 1/2. This equals 27, and 9 to the power of 1/2, this equals 3, and minus 1/6 minus 1/2. So you see, we will get the same thing like we got here. So the answer, after we evaluate this, the answer will be the same thing, will be 32/6.